Alright guys, here we are back with the last problem from chapter 1, 9. It got cut off in the last video. So I'm going to look at this and see that they're opposite rays and know that this whole angle from 1 to 4 would be 180 degrees. So I'm going to fill in the angles. The measure of angle 4 is 43 degrees. The measure of angle 1 is 71 degrees. And the measure of angle 3 is 2x plus 19. Well, in the problem, it tells me that MT bisects QMP, so that means these two angles are congruent. So I can take that 2x plus 19 and use it over here. Well, I told you before that all of these angles form 180 degrees, so I'm going to add them all up. I'm going to do 2 times 2x plus 19 plus 71 plus 43 and set it equal to 180. I'll get 4x plus 38 plus 71 plus 43 equals 180. Now I'm going to combine like terms. It's really important that before you isolate your variable, you combine like terms. So once I add those up, I will get 4x plus 152, which equals 180. Now I'm going to subtract 152, subtract 152, and get 4x equals 28. Now divide by 4, x equals 7. So in goes 7. I need to find the measure of angle 3, which is up here. I'm going to take my x, plug it into this equation. So the measure of angle 3 equals 2 times 7 plus 19, which is 14, plus 19, and the measure of angle 3 equals 33. 33 degrees. Alright, so that's the end of chapter 1. Let's move on to chapter 2, reasoning and proofs. Alright, well, it asks me to describe the problem. Okay guys, now we're going to start with chapter 2, reasoning and proofs. For 10 through 18, we're going to be identifying the properties. I look here and I see that what happened is it's the same expression, just flip-flopped. So when we flip it like that, we call it the symmetric property. And then I look down here and I see a plus c equals 2d. c equals 30. And then it's a plus 30 equals 20. Sorry, that's supposed to be a 20. Well, I simply replaced or substituted 30 for c. So this would be substitution. Alright, and think of this one. You are seeing the same thing on both sides. Like when you look in the mirror and see your reflection. You see the same thing on both sides. So we would say this is the reflexive property. Alright, here I have x equals y plus 1. And y plus 1 equals z. Alright, well these are my two commonalities. I'm going to get rid of those since they both have those in common, and I can say x equals z. That is the transitive. You guys are all very good at identifying the transitive property. Alright, and then I look at 14, and I want to see what's happening. Well, 3x plus 8 equals 20, and then 3x equals 12. I simply subtracted the 8 and subtracted the 8, and that would be the subtraction property. What did I do? Subtraction property. Alright, and what am I doing to PQ equals 16 to get it to be 2PQ equals 32? I'm multiplying both sides by 2. Multiplication. Property. Alright, and if R is the midpoint of TS, here's T and S, and if R is the midpoint, TR is congruent to RS, that would be definition of a midpoint. Keep in mind, guys, they're using the word midpoint. It kind of gives us a clue. All right, and again, you'll notice AB equals CD and CD equals EB. They just flip-flopped. So again, that would be symmetric. And if B is between A and C, so here's A and C with B between it, AB plus BC equals AC. We would say segment addition. We're taking one part of the segment, adding it to the other part of the segment, and it equals the whole segment. All right, so if A is supplementary to B, so A and B, they form a straight line, and G is also supplementary to B, then what must be true? So here's G, supplementary also to B. B is still the same measure. Let's say B was 100, and B is 100. Then G has to be 80, and A has to be 80, which means they'd be congruent supplements. All right, so that's number 19. We'll move along to number 20, and we're going to write the conditional form. Remember, the conditional form is just putting something into an if-then. So I'm going to say if all drivers are, I'm going to say if you are a driver, then you are over 16. Okay, and it wants me to identify the hypothesis. Well, the hypothesis is always the if. So, if you are a driver. And the conclusion is always the then. So, you are over 16. And then we're going to think about the converse. Remember, we talked about the converse being a shoe and another type of shoe is a flip-flop. So we're going to flip them. So, if you are 16, years or over, then you are a driver. Well, I know a lot of 16-year-olds or 17-year-olds that don't have their license, so that would be a false statement, because just because you're 16 doesn't mean you're a driver. So inverse, that means we look back to our original conditional statement and we negate it. We put a not in front of it. So if you are not a driver, then you are not 16 years or over. Well, think about that. If you are not a driver, then you are not 16 years or over. Well, what do you guys think? If you are not a driver, then you are not 16 years or over. Well, again, you could be a driver who is, you're 25 without a license. Well, you're definitely over 16, but you're not a driver. So, false again. Contrapositive. That's where we take the inverse and we negate it. So, we are going to take the statement we are going to take the statement from the converse where we flipped it around and we're going to negate that, put a not in front of it. So, if you are not 16 years or over, then you are not a driver. All right, well, if you're not 16, then there's no way you can be a driver, right? We have to be 16 in order to legally drive in the U.S. So we're going to say this statement is true. All right, we're going to move down now to our laws of deduction, our deductive reasoning. And remember, we want to look at our hypothesis and our conclusions to see if they match. It says if I go to a movie, then I'll eat popcorn. If I eat popcorn, then I'll enjoy the movie. Well, my conclusion and my hypothesis match. When that happens, that's the law of syllogism. So I would just write LOS. And then when that also happens, you can get rid of the commonality, the common term. So if I go to the movie, then I'll enjoy the movie. There you go, law of syllogism. Okay, so now this one's a little different. It says, if I miss my bus, then I'll be late for school. Well, my hypothesis and then my statement match. When that happens, that is the law of detachment. And again, you get rid of the commonalities. So, I'll be late for school. In this last one, if the wind keeps up, then we'll lose some trees. So here's my hypothesis, here's my conclusion. All right, and then here's a statement. It's not a hypothesis or a conclusion. It does match with my conclusion, but because it's just a statement, it would need to match with my hypothesis in order to be law of deduction, and it would have to be my if-then, my hypothesis for the second statement, my if, in order to be law of syllogism. So there is no law of logic, and no conclusion can be made. And those are your 3 examples. And that wraps up Chapter 2. We will be moving on to Chapter 1.